Welcome to Bite-Sized Data Science. Anyone that has seen the last two videos introducing neural network probably feel like there is still something missing to complete their high-level understanding. In this video, I'll discuss still at a high level the questions I would have. In no particular order, the questions are: do I have a choice in initializing the weights? Should I worry about it? We saw the ReLU and sigmoid activation functions. What other activation functions could I use? What are my choices of the optimizer and loss function? Anything else I should worry about? The way I'm approaching these questions is by simply looking at what is available in the Keras API. That gives quite a wide selection. Without going into technical details, I'll give you my opinion where I can on how to approach this. Let's get started. Do I have a choice in initializing the weights? Keras includes the following initializers. We already know that we don't want any weights at zeros, and we don't want them all at the same value. So obviously, some of these initializers are useful in other contexts that are not relevant for us at the moment. The key is that we want something that randomly initializes all the weights. Luckily for us, the dense layer includes a default initializer called GlowRot Uniform. In fact, all the other layers available use this initialization function. We know that the weights were initialized properly in our example, so I suggest we keep this one until we have a reason to change. Next question. We saw the ReLU and sigmoid activation functions. What other activation functions could I use? The Keras documentation lists 13 activation functions. The ones I've seen mentioned the most are softmax, ReLU, sigmoid, and 10x. The important part to know about is the range of values returned by the activation function. Softmax returns values between 0 and 1, ReLU returns values between 0 and infinity, sigmoid returns values between 0 and 1, and 10x returns values between -1 and 1. Many neural networks seem to favor the ReLU activation function. Also, in his book, Deep Learning with Python, François Chollet, the creator of Keras, provides the following table. This answers the questions about which activation function to use in the output layer, depending on the type of problem we are solving. At the same time, it tells us the loss function to use. We'll leave it at that for the loss function, despite the fact that several other loss functions are available in Keras. Moving on, what are the choices of optimizer? The optimizer figures out how to update the weights based on the loss. The Keras documentation mentions 7 optimizers. The first one on the list is SGD, or stochastic gradient descent. All the others are variant of SGD. In the example in the previous video, we used the RMS prop optimizer. This should be fine in most cases. Finally, anything else I should worry about? The neural network we looked at is based on dense layers. In this type of neural network, we have to decide on two main things: the number of layers we'll use, the number of units per layer. The end goal is to get a model that fits the training data as well as possible, but does not overfit as to lose the ability to score data it has not seen. A big part of creating a model is to find the right balance between the two, overfitting and generalization. In addition to the number of layers and number of units, there are some functions that can reduce overfitting. This is something to look into at some point. I'm sure we'll revisit these issues in future videos. There are other types of neural networks that we have not seen yet. This is something you may want to learn about, especially if you are getting into image recognition and text analytics. This is also something for later. Hopefully at this point you have a better understanding of neural networks. See you next time on Bite-Sized Data Science, and don't forget to subscribe.